Have you done the first?
I don't know how to done this.
Okay. So we have an isothermal process, and this process is also reversible. Please remember reversible and isothermal process. Good. Then what do we have? If you remember, the work done by an isothermal process can be calculated as nRT ln V2 over V1. If you do not remember why do have this one, you can start from the beginning. All right? From the beginning, and then you re-establish the expression to calculate the work done by an isothermal process. But this one you did several times already. So for people who still cannot do it, it will be a big problem for you. So this is the work done by an isothermal process. Now, for an isothermal process and reversible process, we can easily calculate the change in entropy as the ratio between heat and temperature, because the temperature is constant. So in this way, you should have the result for change in entropy. Okay. Here we know that if we apply the first law, what do we have? For an isothermal process, the change in internal energy equals 0, right? Remember that this one is equal NCV delta T. Delta T, and because delta T equals 0, then we have it equal 0. Okay, and the change in entropy for all reversible and adiabatic processes equals 0. Here, we should mention that we are talking about processes in closed system. If in a closed system, then we have this one. If in open system, we may have a change in entropy that is negative. Okay, closed system. Is it good, but Bách ơi, where are you?
Do you hear me? It's a bit loud here.
Oh, good. So do you understand?
Yes, I still understand what you're saying about heat.
What did you say? I don't hear it.
I still understand, sir.
Bách ơi, em dùng camera xong rồi em cứ tua đi tua lại cái ấy à?
No, sir.
Tôi có nghe thấy em nói đâu. Trước mặt tôi là cái hình ấy, em cứ lắc đi lắc lại ấy chứ. Cái này lần trước tôi đã có một bạn theo kiểu này rồi nhé. Chứ còn lúc em nói thì em ra một kiểu và video của em ra một kiểu. Riêng bạn Bách hôm nay thì tôi không điểm danh nhé. Và nếu cần thì mời ra khỏi lớp. Mà thôi.
Các bạn nghe em hơi tối rồi ạ, cho nên em gửi cho sáng.
Mà tôi đã bảo các bạn dùng camera là các bạn dùng camera, chứ không phải các bạn dùng các cái trò như thế. Không phải tự nhiên tôi gọi tên em đây. Cứ lặp đi lặp lại một cử chỉ thế. Làm thì không làm gì cả. Các môn khác cũng thế à? Tí tôi xem lại camera các buổi khác. Tôi xem lại record các buổi khác, nếu cũng thế thì riêng cậu Bách này tôi không cho thi. Học một cái như đùa ấy. Làm được bài 4 à? À. Bách. Tôi cho em chuẩn bị bài 7. Em chuẩn bị xem như thế nào. Để xem làm được tới đâu. Tập trung vào. Tên tướng người toàn làm những mấy trò linh tinh. We continue question 4. So what do we have? We have a block. And we know the mass, we know the, how to say, specific heat. Then we can calculate, right, the heat, the energy absorbed as heat. So Q equal mc delta T, right? And then if you want to calculate the change in entropy of the two blocks coming to equilibrium, then we can apply the equation of the change in entropy. And we replace it. Yeah, we replace the heat. If you replace the heat here, you will have this expression. And then you replace the value for this expression. You would be able to have the final result. Question 4 is very easy. Any questions so far? I suppose not. If you have any questions, you need any explanation, or you need to ask something, please tell me. If you forget something, for example, I can tell you to recheck the slide, what part of the slide, so you can see, you can find the answer. If you do not say anything, I suppose that you understand already, and then I will check it. Good. Question 5. For the question 5, we have to calculate the entropy change of the two cases. The first case, we have ice turning into liquid water. And the second case, we have liquid water turning into gases. Okay, evaporator. For the first case, if you remember, when the substance changes its phase, the temperature doesn't change, right? Then this is an isothermal process. This is, of course, reversible also, since we know that we can put the ice, the liquid water into the ice again, or the gas into the liquid water. So we have a reversible and isothermal process. Then we just have to calculate the delta S equal this one, right? Because the temperature doesn't change. Similarly, we have for the both cases, we can use this formula. And remember, if the ice is melting, we have to use the heat of transformation. If the water is turning into the gas, into the steam, I mean, we have to use the heat of evaporation, and you have the result. So the question 5 is also very simple. Now, please do question 7, question 8, 7 and 8. If you want, you can take a break, but after 20 minutes, yeah, we will see the solution of back for question 7. I will also ask some questions to see if you really understand. And question 8 is very long, so please take time, stay focused, and then you do question 8. it is also quite long. So I put it here. And after 5 minutes, I will change to question 20 and 21. If you have the solution, please send me. We need to spend a little bit more time to do several applications of the second law, so the engine and the refrigerator. Okay. Engine, refrigerator. Okay, let us move on. If you haven't finished the question 9, since it is very long, you can capture my screen and then you do it later. Anyway, I will also upload it for your revision for the final exam. So don't worry. Tôi sau khi tất cả các cái buổi, tôi cũng sẽ upload cái này lên cho các em để chuẩn bị cho exam, cho final exam. Okay. So I think we have to move on. We have to do the question 20 since yes, I started to receive some solution of question 20 and then 21. For the question 20, we have our engine, our motor of a refrigerator. So we know the power of this air motor. Then we should be able to calculate the work, right, done by this motor. Actually, the work done is the power times the time. Okay, then we have this. And please remember that the purpose of a refrigerator is to extract the heat from the cold reservoir and put it into the hot reservoir. So we extract a certain amount of heat from the cold reservoir and put it to the hot reservoir. And the coefficient of performance can be calculated at this one. Then if we want to calculate the heat extracted from the cold reservoir, we can refer to this expression. We know the work and we know the coefficient of performance. If you still don't know how to, what is the expression of the coefficient of performance, then please reopen my slide. So this one will equal TL over TH minus TL. Yeah, and you have the work here. You should have the final result. Good. Question 21, what do we have? We have an engine connected with a refrigerator. And what we want is to establish a relationship between Q3 and Q1. So what we want is to have the ratio Q3 and Q1. This can be considered as the efficiency of an engine. The purpose of an engine is to do work. Phải không Phạm Việt Tuấn?
Em đây ạ.
And this work is to provide for the refrigerator to remove the cold reservoir from the cold reservoir a certain amount of heat and then put it in the hot reservoir. Then we can write the efficiency of this engine. So this is the definition, okay? And this one should also be equal to this one, right? This is the definition of the efficiency of the engine. So firstly, you have the first equation. You do the same thing for the coefficient of performance of the refrigerator. You have the second equation. Good. Should remember it. And now you have it. Is it okay? Q4 here is actually Q3 minus the work. You know it. You should know it for a refrigerator. Then you have the third equation. Here, where we can substitute an expression of the work that based only on the temperature and the heat. Because of what we need to find, what we know is the temperature, only the temperature. And what we want to find is the relationship between these heat. Okay, then we should find an expression having only the temperature and only Q3 and Q1. We substitute here to the questions, to the equation here and here, and then you solve it for Q3 over Q1. Please, if you do not understand, you can redo it at home. But at the end, you should be able to establish a relationship, an expression for Q3 over Q1 that depends only on the working temperature. So this is our purpose. That depends only on the temperatures, working temperatures. T1, T2 is the working temperatures of the engine. T3, T4 is the working temperatures of the refrigerator. So we have the ratio Q3 over Q1. Okay, and this is like the coefficient of performance of this whole system. This is for the question 21. Do you have any questions for the exam, for the midterm exam, for the solutions, for anything? So please profit it because this is the last session. We officially work together.
Can I ask about the time and the number of the questions we will have?